we go. Give me one more second here. That way, there's still a way for me to open up chat. I can keep an eye on chat a little bit as well for questions and such, and getting that all moved around. All right. Welcome, everybody. Thank you guys for having me. I do agree that I would love to get up to Chicago. And once we get past all the pandemic issues going on, and that would be very exciting. And I've got some friends in that area. And in fact, my wife is from Illinois, a little lower, closer to St. Louis. But anyway, I got some family over there. And so it'd be exciting to get over there. Tonight, we're going to talk about microservices and really how this is going to be kind of a generalized overview of getting started with them. And we're going to talk a little bit of how easy it is to kind of head down the wrong direction. And so we're going to show that the microservice architecture takes a lot more consideration than you may expect. And with our agenda tonight, we're going to talk about what are microservices, why should you use them, when should you not, talk about some challenges regarding microservices and the architecture, and a lot of the fallacies that come along with them. As well, we're going to do a high-level decomposition example. And I do mean really high level because I'm going to talk a little bit about domain-driven design, and it's a beast in itself. And if we were to do justice to it, we'd need a week just talking on that alone. So normally when I'm at a conference and in front of a physical group of people, I'll ask, what is a microservice? Give me some example of definitions of such. And usually I'll get about 3 or 4 different examples of definitions and such. And it kind of brings up the point that there's really not one good, solid definition out there. There's several good ones out there, but not one. Now, I'm not going to go and attempt to actually be that person to supply a version, well, a solid one that's going to be widely accepted, but I did kind of come up with my version of a definition. And that a microservice is simply a tiny monolith with a tight focus on a domain. It's not about size, not about code size. It's about focus. And this talk is going to help talk a bit about that and how when we say it's a monolith with a tight focus on a domain, we're going to talk about those details and kind of really make sure that that sits in. And it's definitely not about the size of the code. The word micro it's more of an unfortunate term. It's more about just enough code to do a single service and to do it well and nothing more. So there are some tenets about microservices. And the first one is independent applications. So coming back to that, like a monolith, right? Independent applications. And you're going to hear me say that over and over through this presentation. They are independent applications. These microservices communicate over a network versus when you do an in-memory call of a function that exists someplace else in the memory. And when microservices are called over a network. So one of the problems is they incur that latency. And microservices have a single responsibility. And I'll say when you do microservices well, they will have a single responsibility. And on these, we're going to dig a little deeper on these as we go on. And microservices should be owned by one team of developers. Do not have it spread and owned by multiple teams because you're going to see a competition of deadlines and requirements, coding styles, etc. And being that microservices are independent applications, they also need to be individually deployable, meaning that they should not be dependent on other things. Again, we're going to dig deeper on that one just a bit. And moreover, microservices is an architectural style. It's more about the understanding of how the architecture of what needs to communicate with what and for what purpose, more so than it is about coding styles. All right. So we keep hearing this term monolith. What exactly is a monolith? And really, is it all that bad? So the term monolith is not bad. All it is a single code base with a lot of functionality built in. And what makes a monolith bad is usually us when we let something live for year after year and functionality after additional functionality, after bug fix, after band-aid, after more sauce on the spaghetti code, it just turns into this big ball of mud called BBON. There's a term for that, big ball of mud. And when it becomes out of hand and it becomes fragile, that's when monoliths become a huge issue. But the monolith, or otherwise known as an N-tier or layered tier type of architecture, is not in and of itself a bad thing. So as we're looking at monolith as being a single code base with different pieces of functionality in them, with a microservice, generally what you'll see is that that service will be extracted out to its own microservice. You might even build a new microservice with brand new functionality, and rarely will you do a total migration where you're coming from a monolith with several bits of functionality into nothing but microservices architecture. It can be done, and it's very expensive, and I'll talk on that more as well. And there have been people who have successfully done it, but not without the problems. So we'll touch on that. And again, microservices architecture, one, it's an architecture, and it's an implementation of distributed computing. The idea is that we're going to spread the computational needs across servers. Instead of saying we're going to get 5 servers and we're just going to duplicate all of the code, which is a possibility, distributed computing is when we need to share the love. We're going to push out that computational needs across different servers. And because we can have different servers and different choices out there, it actually allows us more opportunity for different architectural pieces. So why should you use a microservice? Well, as I put, to deliver business functionality quicker, safer, and with more stability. Well, here's my humble but correct opinion, if you will. Um, when you get that big ball of mud and your code is becoming more and more fragile, it takes more and more time to implement different features. When the company that you work for says, look, we've got a new feature, we have got to get this out. If we can be the first one in that industry, it's more money for us. Time to market. And that time to market can be critical. Yes, I know we always say that it's easier to do clean code from the beginning, but usually you ended up in a large spaghetti code of a monolith before you realize when and where you should have made some clean code. So along with that comes the, yet another feature request that could make or break a company. And that time to market is critical. That's going to be, in my opinion, the number one reason you're going to do microservices. When you've got to get something either extracted out or new functionality added and bring it into a microservice so that the monolith, that the spaghetti code, is touched as little as possible. So all that fragile code is touched as little as possible. So with microservices, there are 4 main areas that, or tenants or areas, whatever you want to call them, that microservices will give you. And that's one of them is team autonomy. By using microservices, you can choose the best programming language for the job, meaning that, for example, I'll give you a real world example. Something I worked on is I worked at a company where most of the code was written all in C#, except for the new things that we needed to bring in. This was a new feature add to the company, and we were going to do some analytics. Well, although C# can do some data analytics, Python is just better at it. And especially when the team of doing the data analytics already knew Python. Great. So it allowed those microservices to be developed in Python, best language for the job, and it allowed the separation of programmers so that we didn't have to come up to speed on a new language. They could be leveraged and do what they do best. So it allowed them to focus on what they do best, and that's what I'm referring to with that focused development. So it allows that team for the microservices to focus specifically on what they're trying to get done in that realm. If you happen to already be using Agile or Kanban, that works very well when developing microservices. Now, microservices have service autonomy, and they should have single responsibility. Now, what I mean by this is, so most of us may be familiar with a single responsibility principle. Well, think of that applied at a service level. A microservice should have one reason to exist. That doesn't mean one function. It doesn't mean one class, one line of code. No, not at all. It means one single responsibility. If that microservice is to process invoice, then it shouldn't also handle stuff from paperwork for HR, for the human resource stuff. It shouldn't be processing medical claims. Now, if there's a microservice for processing medical claims, that's great, as long as it's only doing those medical claims. That's where that focus comes in, and that's where that micro fits in, is that service should exist to do one thing and do it well. And it's also, when we refer to a domain, we can say that the invoice is a domain. Invoice management is a domain. Medical records, well, that could also be split. Maybe it's medical claims, maybe it's other responsibilities. Well, that just brings up the point that when you talk about a domain, it might actually be able to be split up into other domains. So a microservice should not serve more than one of those domains. It needs to focus on one. And they need to be deployable without other services. This means that if I'm going to deploy this microservice and I'm going to get this out the door, if I have a code dependency that is reliant on another microservice, then you're going to find yourself tethered to somebody else's deadlines when their priorities may not be your priorities. No guarantee that the team you're on is also responsible of a microservice that you're dependent on. So you want to make sure that they are governed by, so that one team owns that microservice. Now, you may say, well, what if we have a brand new feature? Well, it's a little different. They're going to be tied at the feature than they are at the code level. And you want to be very careful of that. And with microservices, it allows you to scale independent of others. And the idea is that you can have multiple microservices and they can run on different types of servers. You can think of it like I deal a lot with Azure, for example. I can have my choice of virtual machines. Do I need the B series? Do I need D series, etc.? And then how many, how much CPU and RAM, let alone, how many VMs do I need, etc. So, but that's the idea, is that it allows me the choice, that I get to choose what is the right programming language for the job and what's the right infrastructure to serve it. And fault isolation. As you're building out your microservice architecture, and you may have a microservice calling another microservice that calls another microservice, you can also build in these fault isolation zones, if you will, or lanes, for example. I saw that statement in a commercial. I thought it was really funny. Stay in your lane, bro. I've just been using it ever since. Think of it this way. If you are running an e-commerce site, let's just pick on Amazon, and you put something in the cart, you go to pay for it, and then there's a failure in the microservice. So the payment microservice may have a problem, but should that prevent others from logging in? Should that prevent others from putting items or searching for items to even possibly put in their cart? So the idea is that you'll have functionality that's calling each other, but they're in different lanes. And for example, if maybe you have a microservice that's failing to put stuff in a cart, but what about the stuff that's already in the cart? It might still be able to be purchased and go through that process, and then inventory, and then shipping, etc. So I mentioned earlier about rarely will you go to a total migration of a monolith to a microservice architecture. Well, here's 3 companies that have done that, but they did not do it cheaply or quickly. They all spent a lot of time and a lot of money trying things out, finding their problems, even having to backtrack a little bit, make those adjustments, put stuff back out into production, try it out until they got it working and working well. It was not quick and cheap. One of the fallacies, right? So you have to be very careful about what the actual effort is going to be to build out a microservices architecture. So when should you not build out a microservice architecture? Well, honestly, they're hard. They just are. And I don't mean to make it sound like a cop out. They just are. They're hard to do. It's hard to do well. But as I point out, so is good programming. So you're going to have those lessons learned along the way. But the other reasons why you should not do a microservice is if your monolith is just too small, and that's a relative term, that's your judgment call. But the idea is that it may actually be quicker and cheaper on your business needs to just simply duplicate the monolith across multiple servers using configuration flags so that each instance is told what it should actually process instead of going to a microservices architecture. Splitting out your monoliths using configuration flags is not a bad idea, and it might very well buy you time to explore other architectural designs that are better suited for you. The other thing is with your monolith, if you simply have too much coupling, too much tight coupling, you're going to have to spend a lot of time refactoring and cleaning up code first. And you're going to have to do some team dynamics. If you have a development team that is not willing or not ready to do microservices, then you're going to have to ramp up. You might have to change team members. You're going to have to spend some time learning, like, for example, this very talk right here, getting pieces and learning those additional things to make microservices to begin with, and then to do them well. And I'm a firm believer that if you're the team that codes an application, then you are the team that supports it. No sense on the support going to somebody else. So you have to have a support structure in place. You know the code, you need to support it. Because if you're going to be, you don't want to be responsible to somebody else's bugs or their bug fixes. So be the team that can focus not only on new functionality needs coming in, but as well as those times when you're going to have to do those bug fixes and those adjustments to get it out the door. And as I pointed out, you're gonna have to spend the time and the money to try things out to find out if you are going in the right direction. So speaking of some challenges, let's list out a few. Starting with what I just said, they're not cheap. Period. They're just not cheap. It's going to take a lot of time and money, and a lot of discussions, a lot of trial and error, and recourse, and figure out what's the best next step. And you may think, well, I just put out a microservice. It's going to listen on an IP address on some endpoint, and well, I can just do an HTTP call to it. That's fine. Using RPC style of messaging is fine until it's not. And that doesn't mean that all of the microservices should communicate just by RPC. You may need to look into doing messaging. So, and the different messaging patterns that are out there, which there are plenty. And as I mentioned earlier, microservices are independent applications. This is where I'm going to keep repeating myself on this. In the past, you may have just copied files to a server, and that was your deployment method. Because microservices are independent applications, you do want to have a continuous integration, continuous deployment pipeline per microservice. And along with that, since they are, again, independent applications, you should have a single repository for each of those microservices. Why? Because as they are independent applications, that means that they have their own set of requirements, their own set of code design, their own the way you guys develop the microservice and the code base, as well as how do you handle the bugs? How do you handle the requirements? How do you handle the life cycle of it, getting it out the door and handling everything about it? The application lifecycle management. They are independent applications, so they have to have all of that application lifecycle management love as any other application. One more thing, as I mentioned, microservices talk across a network. That actually means that us developers need to know more about the network and actually how the network works. We now need to know a little bit about what's called the OSI model, and specifically layer 4 and layer 7. Now, my next slide is going to talk on that, so we'll touch on that in just a moment. Security. This is an interesting one because when we do a method call of something else in memory, it's just sitting there in a DLL that we load up, we make the method call, and we're good. Now, since we're calling something over a network, we're going to have our code calling a service. It needs to be encrypted. I know. I keep hearing this. Yes, but we're on a private network. I understand that. But imagine the information being sent across that network call is your paycheck information. Do you want it sniffed and mentioned elsewhere? See, the thing is, we have to be very, very careful about rogue code, and it is a real thing. If you are using a NuGet package, for example, if you're using your buddy's code, if you're using some person who has a friend in college that wrote some code for you that handles things, it is always possible. That's the key thing. It's possible of having code that's sniffing the network and trying to get data and pushing it out. You have to be careful of that. So now that we're doing network calls, one functionality to another, if that's sensitive data and that may not be your call, you're going to want to encrypt it. So you want to consider TLS. As well, when we say OAuth, and I mentioned that just as a quick example, OAuth for doing the application layer, and we say, well, this code base is going to call this microservice and it's going to get some medical record information. Okay, great. Should any code be able to call that service, or should you be able to restrict it to and govern who can call that? Oh yeah, here's a good point. If you think you're safe inside a network, do a search. Casino hacked through a fish tank. That'd be interesting. I have not heard of that one. That's an interesting point. So the idea is that you still want to secure that traffic and govern who can call that service. Just because it's a microservice, just because it's in a private network does not mean it should be available to any code. Again, imagine it's your medical records. Imagine it's your paycheck, your credit card information. Protect it. Common code. We're going to talk on this one a little bit later in just a few slides. Sharing code. I know that don't repeat yourself code principle, right? DRY, keep it dry. I'm going to show you how actually doing that will make your services tightly coupled. It is actually a problem. We'll discuss that in just a moment. So the OSI model, when we talk about networking and why developers need to actually know a little bit more about networking, when you're going to call a microservice, maybe it's by RPC, for example, we're going to call a microservice that's listening on an IP address at some endpoint. How does it do that? How does it get there? And why do we care? Let's start with layer 7. Well, actually, I'll tell you what, let's start with layer 1, which is physical. That's literally the fiber, the copper, the thing that you can hold in your hand that is either in a data center, maybe it's in your home, it's getting between your computer out to the router, out to the internet. That's that physical layer. But across that, then it starts going up. Like when, for example, when the traffic is hitting like your computer right now in this talk, this stream of data is coming across a physical layer. Then it's being handled through the data and then the network. I'm going to point out that the network is where the IP layer is, the IP addressing. But then layer 4 is the TCP and the UDP packet handling. Then it goes to session and then presentation and then the application. For example, right now, the application is Zoom. And it's receiving all of that information past all of those layers, and then it's showing it on that screen. So why do we need to know about these items? Well, for example, layer 7, if you guys have done any kind of ASP.NET MVC programming, what's the one letter they leave off that's still kind of important? Well, it's R for routing, because when traffic is coming into your MVC application, we know that it's going to get to a controller, but it's the routing at the application layer that gets it to that controller. And then at layer 4, which doesn't care about the application, that's when we worry about load balancers. Because you're not going to have just one instance of a microservice out there and think that it's going to be running 24/7. You'll be proven wrong very quickly. You're going to need to have more than one instance out there so that you can handle those random crashes, so that you can handle server reboots, etc. Well, then once you have more than one instance of that microservice out there, you don't want your code that's calling it to know about every single endpoint out there. That'd be too much load on the caller. Let alone that, you're assuming there's one caller. There could be multiple callers. Instead, you're going to call a single endpoint being a load balancer. And I'll point out, because again, I do a lot with Azure, the Azure load balancer works on layer 4. It works at the TCP packet layer, and then it splits those out to the backend ports there. So we do need to understand how the network works just a little bit, just enough to understand how a microservice could be called. Now, you may just be doing messaging and not doing RPC at all, and that's fine. So, but it's still helpful to know a little bit about networking. So I mentioned earlier about how common code is going to make a microservice tightly coupled to others. If you're sharing a NuGet, let's say, for example, in your organization, you have a custom NuGet package, and everybody's been, sharing this code inside that center NuGet package there. And team A is microservice A, and they've got version 1, and they decided they're going to make a change to that NuGet package so that they can get their version 2 out. Okay, but team B with their microservice is also reliant on that same NuGet package. And sure enough, that last code change is a breaking change to this team for their microservice. So now one team's code decisions have now impacted the deadline of another. This is when it can be bad. So, I know we keep being told, don't repeat yourself. We have this DRY code principle. This is where it breaks down. So inside of a service or inside of a NuGet package, no, you should not be duplicating code. But when you have a service that's independent of another microservice, then yes, you actually should be duplicating some of the code. Here's what I mean. So now take, for example, that you decided that out of that center NuGet package, you've taken out what is not common anymore, and you split it out across the microservices there so that, yeah, so NuGet package bar and NuGet package goo happen to be the same code, um, maybe for a few minutes, but they were split apart for a reason. They were split apart so that they could evolve independently. Coming back to that, like I said earlier, they're independent applications. They need to evolve independently. That's the microservice and the code it relies on. And you notice that the microservices are still reliant on a center NuGet package. Well, that's because there's just code that they haven't decided that they need to split apart yet. So yes, duplicate some of your code when and where it makes sense to do so. But as soon as there's a breaking change that affects others, you want to avoid that. You need to avoid that tight coupling situation. So my advice then is to separate the code that changes to their own package for the service that needs it. Let me go back a slide here and ask you a question. That center package, see, we know that service A is owned by team A and microservice B is owned by team B. Who owns NuGet package there in the middle? That's kind of a problem in and of itself, because that also shows that there's competing deadlines, competing judgment calls on what should be there and how it's designed. So definitely try to avoid that. Okay, so you're going through this talk and you're like, okay, I'm kind of getting it, but still, I really, really want to make microservices. I still think these are super, super easy. So you decide to go ahead and build out a microservice and you start moving functionality over just to realize it's dependent on another set of code that's also dependent on another set of code. And then all of a sudden you realize you don't have a microservice anymore. You don't have that single responsibility. You just built yourself a second monolith. So here's why I bring this up. Is this bad? Well, it is, but here's why I'm going to say it may not be. It is bad if you stop here. You know, you're headed towards building out microservices and you end up with another monolith. If this is something that you can go a sprint or two and you already have plans in the backlog on how to further split this apart, then what you've done is you've built yourself time as long as you have a solid direction in this. If you don't, then yes, this is bad. It's just more headache for you. It's yet another application to support that's not truly hitting the goals of what you need. Okay, we're going to shift gears into one more thing that's actually been kind of a hot topic and very debatable. Decentralizing data. See, when I was learning about this, and I was learning that there's a rule out there that says that every microservice that persists data, not all microservices actually persist data. Sometimes they just chew on something and they give out an answer, and there's nothing persisted. But if a microservice persists data, then it should have its own database. And when I first learned about that, I was against it. I didn't get it. That I was like, no, you know, I've grown up in having a large SQL server, backend, single repository. You don't split things up across multiple applications like this. It doesn't make sense. Here's exactly why it actually does. So let's look at our example here that we have a monolith with no microservices yet. We have a monolith that's using a SQL server, a database backend. It doesn't have to be SQL Server, it could be. And now imagine we've got tables for accounts, customers, orders history, parts one, shipping history and logging. Parts one. Well, here's the deal on parts. So this application's been around for years. It's had change after change after change. And although there's code changes, there's also changes to the schema on these tables. And so the parts table has gotten so much schema changes, and then it was kind of got itself into a bind. And so what do? We build out another table, and even worse, we decided that parts one is a good name because naming is hard. I hope I'm not the only one that's ever done that. So the idea here is that the schema changes, and it's the schema that is our problem. So let's continue on. I'll show you what this does. So as we build out a microservice for parts, and as we have a parts microservice, then the parts microservice becomes the single source of truth of the information all about parts. And then we have an orders microservice, and it's the single source of truth of all things orders. But it also has a reliance on information on parts. And then we're going to add yet another one, and we add our shipping microservice, and it has a reliance on orders data. Okay, now one option that you've got is that you could have a microservice to call another microservice to get that information. For example, if something is calling the orders microservice and it says, I need to get this information from you, well, it does a call over to parts and says, okay, I need this information from you so that I can fulfill that request. That's possible and it's doable. But yes, yes, I know DBAs are crying. I hear that. Yes, you can have microservices calling other microservices to on the fly gather data, and that's fine. But you may also see and get to a point where, it's just overly chatty, and maybe there's additional latency in there. Maybe that the requirements here that of what's calling orders and needs that parts information is taking too long if a microservice is calling another microservice. So what do we do then? Well, let's take a deep dive into that parts microservice real quick. Now, if imagine that we had information about a part, we have an ID, a natural key, a part number, part name, category, classification, description, size descriptions, color, container, manufacturer, manufacturer's part number, manufacturer's date replaces the part number and discontinued date. Fantastic. This parts microservice is the single source of truth of everything related to a part. Now, the orders microservice needs information about a part, but not all of it. It only needs just enough of that information to fulfill what an order is. When you look at an order, it's not really going to have all of that the previous part number, the manufacturer's date, when the manufacturer became a company, and all these other details about a part. So what is actually a viable solution is to duplicate data. Are we screaming, crying yet? Just as I said that it's okay to duplicate code where it makes sense, it also applies to code to data, because at some point it's the schema that's actually tightly coupling you, and you need to avoid that. So when you find yourself with multiple microservices and maybe you see enough latency in there, you say, let's go to the next step and let's duplicate data. So now the orders microservice has just enough information about a part that it can do its job of being an order. Now, how, because I hear the questions rumbling inside the brains right now. Yes, but if there's duplicate data, how do you keep them in sync? How do you get that one bit of data to multiple microservices? That's where messaging comes in. Now imagine that, let's just say that we have an administrator on our e-commerce site, and they are adding a brand new part to the organization. So the monolith will send out a new message and, well, about a new part. Well, order is not going to listen to that message because it doesn't need to worry about new parts and to be inventoried. Instead, well, shipping doesn't need it because they're not going to ship anything. So the parts microservice will pick up on that message and add that information to its repository. So now an order comes in and maybe our monolith here, maybe that's a e-commerce front end, maybe a web or something like this. Okay. Jim, I like the way you're thinking. Let me touch on that in just a second. So imagine an order is getting ready to come in. Now the monolith does not create the order. In fact, it sends a message that is picked up by the order microservice and says, here's some information. I need you to create an order. So the order number is provided by the single source of truth order microservice. Then it sends a message saying, great, here's an order number. And it sends it back to the monolith, says, thank you very much, and can email it, sends the notifications or however that's going to be done. Now, with that order being created, then the shipping department says, well, yeah, I need to know about that so I can fulfill the order. So it's reacting to that order created message as well. So let me touch on that right quick. A monolith will send a command, says we have a new part. The monolith will send a command saying we need a new order. The order microservice sends a event, not a command. It sends an event that says, hey, I created an order. So the monolith is aware of it, and the shipping microservice then becomes aware of it because they're listening for that type of event. So one message can be picked up by multiple endpoints or multiple code bases, Monolith and microservices, both, to react independently. The order microservice doesn't care about who's reacting to that event. It just knows it needs to send out a message. Now the monolith, or maybe an administrator says, wait a minute. We noticed that there's a typo in a part name. So the administrator pulls up that information and it goes to their screen, information from the parts database. And they say, all right, well, we're going to update this typo and get that fixed. So it sends a message out to the parts microservice. Now, that's not going to be a command. It's more likely going to be an event because the event is going to be sent out and the parts microservice is going to listen to it and says, oh, I need to go and update that typo, get that fixed. The order microservice picks up on it and says, well, if I got any orders with that part, I need to go and update that duplicate data. So one message, people listening onto it as they need to, can react to those different types of messages to handle how data is duplicated and to help keep it in sync. Now, let me touch on data warehousing. Now, what happens then if we have all these databases, and I know a DBA is going to be like, great, you've just given me that much more to manage. Sort of, yes, but these don't have to be database servers for one. They don't have to be. They could all be in the same database server. They could be separate databases. They could be different database servers, meaning that maybe the monolith is working with SQL Server, and maybe the parts database is working with Cosmos or DynamoDB. The idea then is that you also, not only do you get the best programming language for the job, but you also get to choose the back end data store that's appropriate for the type of data being stored. Now, along with that, if you're going to have and house a lot of this information, what else needs to keep a good copy of everything? I am a huge proponent of do not report from a transaction database. That's the wrong purpose for it. So where am I going to pull reports from? I would spin up probably another microservice with a database, and all it does is store data. And then it becomes the data store to report from. So yes, now you may feed a data lake, however you set that up. So however you build out that data warehouse, I would add another endpoint off of the message, listen to all the appropriate messages that I need to, collect all the data so it can be reported from there. So hopefully that helps a little bit. Okay, so there's another type of message in here that I'll touch on real quick because I'm kind of behind on time right quick. Let's go through this one more time. Let's think of a saga. Now, a saga is more about with a distributed system, imagine these different states that an order is. Oh, is this the point where you mute my microphone? Sorry, I just now saw that. No, you don't get to mute this. Sorry. Now imagine the scenario where the saga is about the different states that a item can go through. In this case, in this example, it's going to be an order. Now, something I do in real life is that I have multiple checking accounts, and I have one specifically for internet purchases. I'll put in $200 over there, and I will buy things over the internet. Yeah, it's usually Amazon like everybody else. But there are times when my wife will order something, I'll order something, and well, the bank account got a little low and we just didn't know. And so we order something else. So on Amazon, so what happens is that an order gets created and then we get an email says, thank you for your order. We appreciate that. We'll get that sent to you as soon as possible. And then a few minutes later, we get an information back from the payment system that our payment failed. Oh, okay. So inventory was already told of the order, but they were also notified that the payment hasn't successfully gone through yet. Or let's change the scenario a little bit. The saga says, we're going to go and create an order. Order has been created. Great. Let's go and create issue a payment. Payment fails. Oh, okay. Let's undo. Let's go through all the undo steps. So it reverts. It comes back to order and says, well, payment failed. You need to undo. Well, it doesn't make sense to delete an order created. Instead, the microservice has the freedom to change the status of however it needs to individually. To maybe in this case, instead of deleting the order, it flags it for payment pending, something to that effect. And then another system says you need to go notify the buyer that their payment failed. All right, payment's been updated. Great. They've been notified, payment updated. The saga has been updated, says, great, let's go try it again. Payment then succeeds. Saga is updated. Inventory is notified. And then they send the information, ship the information, the product out. So with messaging, you can use a saga to help manage the state of an item. In this case, it's an order. All right. Let's do some decomposition, but again, we're gonna have to stay real high level and because I'm really running out of time. Okay. So we have our monolith, which got a, that set of code base, right? It's just really large code base. It's got a lot of independent functionality in there, a lot of services in there, so to speak. And our attempt is that we're going to make a microservice by extracting some of that functionality away. Now, I don't know about you, but all the many years that I've been a developer, I've never seen a monolith as clean cut as that. It's usually got functionality with blurry, not well-defined lines. So you're going to have to spend some time defining those boundaries, cleaning that up, and maybe even using some good dependency injection to clean that up a bit. Spend the time refactoring. And now that we're talking about getting started with a microservice, where do we begin? This is a common question I've gotten in the past, so I made a slide for it. Considering that microservices are independent applications, they need their own CI/CD pipeline, they have their own requirements, they need their own code repository, they need their team, they need to be up to speed on things. you're going to spend a lot of time learning. You still have to build the infrastructure. The infrastructure doesn't care how big the code is. It just has to be there. So if you're going to start small. Start with a small bit of functionality. Find something really tiny that you can either add to the monolith or pull from the monolith. Okay, so we're going to do a little decomposition talk, and we're going to talk a little bit about domain-driven design, but it's not the only way. Domain-driven design, created by Eric Evans, was not created for the purpose of microservices. It just happens to lend itself really, really well. So we have an example company of Wham Bam, and they make fidget widgets. I actually have one in my hand right now. They make a fidget widget. They are a production company. They're not a software development company. They're not an accounting company. So I bring this up because it's their primary domain is a production. And you have other ancillary domains, purchasing and shipping. They are required to be there, but they're not what makes the company unique. The company itself is a production company. Yes, they need to purchase raw material to make their products. Then they have to ship it out. Then there's also a generic layer of domains being third-party integration. Maybe you got accounting, invoicing, and returns management, things that could be purchased off of the shelf, some software like that. It doesn't have to be built in-house. Maybe it is. Those are going to be your generic layer of domains. I mentioned event storming. I don't have time to talk on it right now, but I encourage everyone to look up event storming. It is a great way of looking at existing code, looking at existing functionality, both with developers and subject matter experts, which are called domain experts in this, to learn about the flow of data. Maybe that's how an invoice is processed. Maybe that's how a return is done. How is a warranty handled? How does purchasing a raw material actually become a final item to be shipped? And where does the code come into that? Okay, so now I'm going to focus in on the purchasing domain and the production domain. Let's dig in a little bit there. Okay, so we're looking at some functionality here, and we notice that in the purchasing area, well, we've got, they purchase raw parts, and they also deal with vendors, okay? And over in the production area, well, they have parts that they assemble to create their final product. And they only build them because of the order that came in regarding that. So the first thing that, and this is regarding domain-driven design, is that we notice that we have parts and we have parts. So with domain-driven design, one of the main tenets with that is that you should have a ubiquitous language, which means that as you're looking at these different pieces and you notice things are ambiguous, find a way to change them so that they are not ambiguous, so that they become ubiquitous instead. This means that even going to our namespaces in our code, our class names and our method names, and as well, if you have somebody that's new to the company or new to the team, they could look at your code and by the names, be able to get at the very least a gist of what's going on and why. Because for purchasing, when they say parts, to them, it's purchased parts. It's that raw material that they buy. But for people that are subject matter experts for production, they don't buy raw materials. They assemble parts and then they produce a final piece that gets shipped out. So it's speak the language that is appropriate to those experts. And when you even apply it to the code level, it helps developers stay in line with what is the purpose and what business needs that they are fulfilling. Okay, so let's dig in a little bit more here. We're still in now we're actually only in the, let me back up. I missed an entire piece and let me touch on this because it is a big item. So we're looking at the things, we're looking at the code and we're saying, you know what, these bits of functionality, these things relate together and they don't have reliance on other things. We could draw a circle around that. So we draw a circle and we call it purchasing. Then we notice the same thing for the production area. We draw a circle around it. We call it production. Those are the bounded context. I wish I had more time to talk about in context tonight, but I just don't. I highly encourage you to dig into it. When you learn about domain-driven design, understand ubiquitous language and understand bounded context. And when that really sits in your head, things will become a lot clearer regarding domain-driven design. Okay, so we're in the production bounded context. Now we're actually looking at code. This is class level stuff. So I have a class for orders and I have a class for order lines because an order contains more than one order line. And products is made up of assembly parts. So I have a class for order and a class for product. And you notice that they are the top of what is related to them. An order is created of order lines, right? And these become what are known as aggregates. And the order and the product classes are aggregate roots. And if you notice where you have that sense of a main class where it deals with all of the composition and it's the head of functionality there, that's an aggregate root. And one of the rules about DDD is that any code that's in an aggregate can call another aggregate, but it must go through the aggregate root to do so. Now, imagine that if there's, for whatever reason, there's code in handling an order line and it decides to call over and to adjust something about the assembly parts, you actually risk data integrity. So if it actually needed to be called over there, that functionality needs to be presented at the product class and presented there. And then if it's called, then the product class can have functionality that says you may change something about an assembly part, but I also need to know about it and do XYZ and call other things for the purpose of data integrity. Okay, so now we're looking at the functionality that an order class provides. We're looking at the functionality that a product class provides. And then we say, you know what we could do? Let's draw a box around this thing and call it a service. So this is a possible service, a possible microservice you could build this out of. So we're going to have a production microservice, and it handles things about it. No, it's not the single source of truth of orders, but it has code to understand about an order and about how to handle things in there, as well as product and how to assemble parts. So you're exposing functionality, and now this is your microservice, and you have a single bounded context in here. Now, a rule is as well that a microservice can have one or more bounded contexts in them. But what you will not have is when you have a bounded context that's shared between microservices. Again, a microservice is an independent application. And so if you have a bounded context that's split between the two microservices or more, well, one, who's to say that it's one team that's governing them all? And although it may be one team that started out with these two microservices, maybe there's a change of ownership. But then you have competing challenges and you could have common code in there that you want to avoid. Now, there is an exception to this. There may be a bounded context that is actually shared between microservices. I just told you don't do this. Now I'm telling you that you might do this. I hate it when you hear those kinds of things. Never do it. Okay, but here's when you might. Everything that's on the screen right now is about business logic. Very specific to the business, that is to get things out the door for that functionality. But the bounded context that is not surprising if it's shared across multiple microservices is for cross-cutting concerns. You may have multiple microservices. You have independent applications. You have that business logic that is separated into those microservices. What is in a cross-cutting concern? Maybe there's an agreement across multiple teams on how to log information, how to do log aggregation and do the monitoring, and how those other lower layer infrastructural pieces in there. They're not specific to the business logic. Instead, they're about supporting microservices, and you are going to need log information out of there. Because one thing I did not touch on is that troubleshooting and debugging microservices across multiple microservices is extremely difficult. You're going to want that log information. having a common way to do that, a common log setup, a common monitoring setup, that's when you'll have that bounded context that's shared, but it's not business logic specific. Okay, enough out of me. Here's a quick review. Microservices are hard. Yes, but so is good programming. You get team autonomy so that you can have the right team for the right job and the right programming language, and you can have the right servers, the right database. You get service autonomy so that the microservice is focused on one functionality of that service and only that bit of functionality. Don't mix things. If you do a invoice management, don't have it also do order creation. Scalability allows you to have your choice of servers, how many instances you need, how are you going to handle it? Are you going to use Kubernetes or such? And fault isolation. So if something happens, it's not taking down the rest of the system. They take a lot of time and money. You need to understand a lot more about the messaging and the calling and the networking of how these things communicate. And since they are independent applications, you're going to want to set up a CI/CD pipeline and a repo per microservice. Don't share code unless you absolutely have to, and be careful because it's going to make them tightly coupled. And developers, please start to know a little bit more about the networking and how it actually operates. And on that, I actually do have another conference talk or user group talk that I can do sometime later on it's a kickstart into Azure networking. That'd be good for developers as well. And encrypt your data and be prepared to control who can call your microservices. We also touched on domain-driven design, talked a little bit about a bounded context and an aggregate. I know it was very high level and I do apologize, but I'm behind time already. Here's the one slide that you're more likely wanting to get a copy of right quick, and that is some recommendations. Microservices Patterns by Chris Richardson, Domain-Driven Design by the author Eric Evans, and Patterns, Principles, and Practices of Domain-Driven Design, PPP of DDD, by Scott Millett and Nick Toon. I will tell you that the Patterns, Principles, and Practices of Domain-Driven Design, when I read that book, it made this Eric Evans' book make a whole lot more sense. It really set in for me. So if you read Eric's book and it just set in first time, God bless you, that's awesome. For me, I had to go and sleep on the book for a while and see if osmosis worked. It didn't. So there's a lot of great information on this, and definitely want to check this out. That is enough out of me. My name is Sean Whitesell. I'm a president of the .NET user group. And yes, I'm a Microsoft MVP. I'm also a cloud architect at TokenEx. And so I've got some friends on Twitch with Developers Garage and Tail Learn Code. I am also a streamer on Twitch, not as often as I want to be. I'm trying to get another personal project out the door. Once I get that done, I will be on there as often as I can be, but I'm usually on there talking about Pulumi, building out Azure infrastructure. And I do stuff on networking, as well as a lot of stuff on C#. So more than welcome to come and visit me there on twitch.tv/codewithsean. Other than that, thank you all very, very much. Any questions?
You can either put questions in chat, or if you want to come off of mute and just ask those, either way works. So.
Oh, thank you. Yeah, I appreciate that, Ian. Thanks for coming. I appreciate that.
So actually, I'm trying to find the mute button here. What do you say to folks who try to tie microservices to a technology? Is there a technology you think we should be looking at for microservices? There's a lot of talk about containers and microservices. Just interested in your viewpoint there.
So actually, very few people know this, but there's actually multiple types of containers. There's not just Docker. There's also Rocket and other types out there. Docker happens to be the most widely known, just like Kubernetes is the more widely known out of a lot of the other orchestrators out there. So to pick a technology, I would say what is actually strong, what is really well supported. Docker's well supported. It's not going to go anyway anytime soon. Kubernetes is well supported. And Microsoft is doing a lot with Azure regarding Kubernetes. And I've done a lot with Azure Kubernetes Service as well. So to say would be careful of pigeonhole to a technology. You're going to have to choose something at some time. My guess is my point is find something that's well supported in the industry, and it's going to change regardless. So that's my quick answer. I saw another question about, do I have a recommendation for event storming? I'll put this in chat. There is a guy's name is Alberto Brandolini, and I hope I spelled his name correctly. Alberto Brandolini is the author of, or the creator of, event storming. Literally a quick Google of the word event storming itself, and this is much different than event sourcing, by the way. But event storming, you'll find some resources on that. There's even suggestions on getting multiple colors of sticky notes. What do the colors represent and why? And how do you have those meetings with those subject matter experts? What tools do I use to deploy and monitor microservices? Okay, well, I do a lot with Azure. So Azure DevOps for deploying, Kubernetes for orchestration, and for scaling, things like that. For monitoring, I've used Prometheus and Grafana. I'm not going to say that those are the only or the best. There's just happens to be suggestions on what I've used in the past. I'll put that in chat just to have the names. Any other questions? Any comments, even any good, bad, ugly? I appreciate the comments. Thank you for mentioning that. I appreciate all being here. And I also appreciate, wish we had more time. I appreciate constructive feedback too. If like there was a concept that was just, I didn't sell well, I'd love to know about it so that I can tweak it. In fact, the slides that you have seen have actually been tweaked from previous talks that I've given. So it's always evolving. Anything else?
See someone raise their hand. Dan, do you have a question? I mean, raise their hands virtually.
Yeah, and I saw a comment, like covering the pitfalls. It seems like there's a lot of potential gaps if you're not thinking things through. That is the absolute goal right there of this talk is, and that's why it's titled the way it is. They are not nearly as easy as you think they are, and to do them well. Now, that doesn't mean nobody should do them. You're going to have to at some point go play with them, go start it out, but be able to give yourself enough time to be wrong and to make those adjustments. How much knowledge of Kubernetes is required to do microservices? None. You can do everything manual, but you will soon realize there's a lot of that manual effort that you don't want to do. I gave a presentation to a CEO, couldn't care less about the differences of microservices or a monolith. But when I told him that we're using Kubernetes, Azure Kubernetes, and he's like, why? I said, because that thing watches over the code. And if that container dies at 2 a.m, I don't get called. It's just replaced. And it's up and running within seconds. And so it was a self-handling system as far as he was concerned. So that was one of the benefits of jumping into Kubernetes. Now, playing with Kubernetes is just like microservices. There's a lot of the easy things you can do, but to do them well, you're going to want to spend some time doing it. And I will definitely do I apologize, I forget the author's name, but there's a book by Manning Publication, and it's Kubernetes in Action. The second edition is in production right now. It's not, well, it's not out yet, I should say. It is still what's called a MEAP, a Manning Early Access Program. But the first edition is out. It's been out for a couple of years. Get the second edition, get the updates. Also, with as much investments as Microsoft is doing with Kubernetes, also watch what they're doing with Azure Kubernetes Service. They're very some exciting things, and you can get up and running on Kubernetes rather quickly. These are great questions, by the way. Oh my goodness. In small teams versus large teams, do you keep some sort of basic contract in terms of data interactions, assuming every service? Oh, that's a big hitter. Let me finish reading this and I'll answer that. Okay. Ooh, Ian, I like the way you think. So, yes, think of it as, if this is a independent application, right? And it may call another, that other microservice may not be on, it may not be by your own development team. Well, what if that microservice is actually not owned by your company? What if it's a third-party system that you're tying into? So then, yes, you're going to have, regardless if it's a third-party system, if it's going to be in-house, you do have to have the agreements in place. And when a service calls another microservice, then you get into versioning. How do you handle the version issues that come up with that? When you need to make a change, how do you deprecate things? And so I wish I had an easy answer for you, Ian, but I would say, think of it as it's an application that has a service level agreement with another system, and it must be discussed. There must be understanding on both parties, and that understanding that I'm calling you, so you cannot just go change things. And by the way, if you're the one developing that microservice and you go just change things without providing a version system in place, you could hurt your callers unknowingly. So there is that bit of responsibility with that. Can we apply design patterns while designing microservices? So a design pattern, if you think of it as a code level, absolutely. Will things like the strategy design pattern, which is one of my favorites, will it come into play? Absolutely. You can still have DLLs. You can still have NuGet packages and things like that. It's just, this is my invoice management microservice. It doesn't do anything else but invoice management. It's its own application. So do you need design? Can you do design patterns inside there at the code level? Absolutely. Are there design patterns regarding microservices? Not like there's a book of them out there like there is at the code level is out there right now. There are some microservices patterns out there. I'm not going to be a good enough authority to speak on them tonight, but I would say treat them as independent applications. You're going to have that service level agreement, and put versioning in place. Handle your callers as customers, even if it's the team next door, whatever. And understand that relationship there. Then you're going to have to get into understanding things like messaging, for example. There are several messaging patterns out there. So definitely learn into those. Sorry, I don't have a better answer for that. Let's see. Just N number of people times X number of teams, a lot of dialogue, understanding to be shared. Versioning is one thing, but yeah, yes, you're right, Ian. And so a team of developers that's going to build a microservice, other teams may not, they may know it's done in Python versus C# versus Java, whatever. But do they need to know all the details? No, they need to know what where it's common to them. And that's going to be that calling, that service layer, not at the code level. Any best practices and tips on coexisting of Monolith and microservices? I don't recommend putting your microservice on the same server as your monolith, because you're probably dealing with issues, not just because of the fragile code base, but you're probably fighting infrastructural issues with where your monolith is hosted on. Now, maybe you got plenty of CPU and RAM headroom. That's great. That's your call on that. But chances are you're going to have a server for your monolith or more, right? For high availability. And then you're going to have other servers for your monoliths, and have that spread out. Be very careful about high availability. I'm a cloud architect, so I never have one server. I have at least two. Those two servers are never in the same data center. They're in multiple data centers. And I control every bit of that. So even want to control it at that aspect. Oh, cool. Yes, you found a good a link on the Microsoft Docs page. Fantastic. And there's probably stuff that if I go look at it, I'll be like, oh yeah, why didn't I think of that? I've probably read that page and completely forgot. These are fantastic questions. These are more questions and more after presentation discussion that I've had at other places. So this is good. I appreciate it. What else?
Your background looks fine. Very nice.
Doctor Strange?
Yes.
Yeah, I'm a fan of Doctor Strange. All right, guys. Well, thank you all for coming out. Oh, here's one more. What about NoSQL versus relational for a data store? Ooh. It's literally like saying tabs versus spaces, because it still comes down to right technology for the purpose that's for the business need there. So there's, I grew up doing a lot of SQL Server. So relational database is nothing for me, but I'm also getting into other areas, well, and I have been, where things that need to be stored differently, be it in Azure Table Storage or in Cosmos DB. So it really kind of depends on the business need that needs to be fulfilled. So if you're coming from relational database, you're more likely to stay with it. If you find yourself with a little bit of data and you can modify that data so that, because by the way, now that you're getting into microservices, this is not one-off type things. It's a distributed computing architecture, and distributed computing is a huge, huge thing in and of itself. Which reminds me, I should have mentioned this earlier. I'm going to put the name of I'll put the name in the chat here in just a second. A very good friend of mine wrote this book, and it's been just recently published, The Art of Immutable Architecture. Fantastic book about how to understand distributed computing. I cannot advocate this book enough. The Art of Immutable Architecture. And if somebody wants to find an APress link on that, that would be great. But The Art of Immutable Architecture. And let me make sure I get that up to here. Okay, so I don't know if I answered that question well enough on relational versus non-relational, but it's really going to come down to technology versus business need. Let's see on my coexisting question, how to route calls usage code from Monolith to the new Microservice. Oh, how to route calls. Okay. So in the microservice, you're going to have to make a code change in the monolith so that it's not calling that that code base anymore. It's going to call new code that says I need to do a network call or a message out to that distributed architecture world as it is. So you're going to have to do some code changes there. And I do recommend putting in like a configuration, a feature flag of such, so that you can govern that. But yes, you're going to have to change the monolith so that it's calling the microservice instead of the service that was already there to begin with. So I don't know if that answers that question on the how to route. It's just going to be a code change. I recommend feature flags. I also recommend, I'll put this in the chat as well, the circuit breaker pattern. There's a library called Poly that you can use with .NET, maybe other languages, that for handling circuit breaker pattern. That is, if I call something and it works, great, things are fine. But if I call it again and there's a problem in that call, it'll try it again. And if it still fails, then it's going to go to whatever you have programmed into a secondary direction. And maybe I can't call a microservice. So instead, I'm going to call this other code base that is, I need to log it, what's happening, what was this for, and then let the upstream know that that call failed. Thank you, David, for the link. And let me get caught up on any tips on convincing holdouts that are defensive or protective of monoliths? So I'm actually a black belt in two things. So you may not need to go that drastic on convincing others. It's going to be the same kind of argument. Like, look, guys, I know this technology that we've been on for the last 30 or 40 years is great and all, but Kubernetes is out, or there's actually a thing called Windows 10 now. So it's going to be those things where you're going to have to show them the benefits of it. And I'll say this carefully: if you can't change your situation, change your situation. Meaning that you can only influence those around you so much. And if you're still in a stuck position, you're not growing where you want to grow, maybe that's not the place that you need to be. And I don't mean just up and leave, but it's kind of a career defining type of thing. So I don't necessarily have tips on convincing people. I'd actually be a millionaire, nowhere near it, because I can't convince enough people. So still working on that one. Mono repo versus multi-repo. I feel like there's still a lot of debate around this, and there's ways to segment changes in a mono repo to fire individual pipelines. Are there strong benefits to multi-repo pattern or pitfalls on them? So I don't know enough to give you a great answer on that. It still comes back to what do you want to have the headaches? Because you've built a microservice. The microservice is an independent application. If you have it in the single repo with everything else, you're going to have a headache of it being able to live independently of the other code base. So there's a headache there. Now you can exchange that and you can build out another repo for the microservice, but then you've got two repos to manage. So you're not going to go without your headaches. It's just which one do you want to do? What you might do, and you might do it carefully, is if you leave it in one repo, at some point you're like, okay, this is enough of a headache. I want to pull it apart. And then you're going to get a far better answer that is actually applicable to you on where you are with the business. So I don't have a better answer than that. I apologize. Is it preferable to assume scaling up front across all services like service discovery, feature flagging, etc., or is it best to have microservices work best for itself? have each. Maybe this is much more of a governance type question. So to assume scaling up front, you need to assume that you're going to have to handle scaling. You're going to have to handle things like service discovery, as you pointed out. Service discovery is a way that if I'm going to call, I mean, like a load balancer. Okay. I mean, that's still a bit of a service discovery. It's in a way. If I'm going to call a service discovery system, and maybe it's a console or a load balancer, console is a, was it CON-SUL as a product that is service discovery implementation tool. You need to understand that, yes, you're probably going to have those arguments. You're going to have those discussions. You're going to have those needs that you're going to have to deal with. You're not going to have a microservice and say, okay, we only need 3 instances and we're good. I've been teaching people recently, there's a phrase called pets versus cattle. Stop customizing your servers. And thank you for the link on console. Stop customizing your servers when you, or your microservices instances. Instead, treat them like cattle. They don't need a name. They need to be ephemeral. They need to be where they can, if they die, they just get replaced. And something like Kubernetes can do that because the scheduler will monitor that. And if one dies, it says, wait a second, I'm below the minimum number of instances that I'm required to have. It will go and spin up another one. So, yes, 100% cattle, not pets. Yes, exactly. Treat even the servers. You want to get to a position where even your servers are ephemeral. If a server dies, you should be able to build one, be it by script, automated, whatever, be able to build one and replace it within minutes. That's what's going to help keep you highly available. Okay. Yes, patterns like event sourcing, yes, sagas and CQRS, command query responsibility segregation. Scaling at the beginning, not a high priority. You need to understand that you will be scaling. And then as your microservices developed, you may be able to answer better as to, well, how are we going to scale this? What is it going to run on? How does it handle scaling for us? So, okay. I'm at the end of the chat. I need to drop here. Thank you, Ian, and others, Mike and others. Thank you so much for the questions. I really appreciate that. Anything else?